one of the most important things to actually find a cure for a disease and is actually understanding what happens in the organ that this disease, what happens in the case of pulmonary fibrosis, what happens in the lung. This has been very difficult. Unlike cancer, in which we usually take out the tumor and we can analyze it, in pulmonary fibrosis, only a few patients get the biopsy, probably a third of the patients. They don't always get to research. So for years, there was a problem with actually understanding what is going on in the lung. My group, almost 18 years ago, started with insisting that we are not going to use hypotheses or insights from mice to drive our research. We are going to focus on the human lung. And we made the big effort, and we use basically a resource that is readily available, which is lungs of patients that undergo lung transplant. And we use different methods. And what we did was profile all the genes that are expressed in the human lung. And over the years, we've identified many novel insights, including the potential role of thyroid hormone as a new therapeutic in pulmonary fibrosis and other molecules. We've also identified new biomarkers. However, this was limited. And the reason why it was limited is because you take the lung and basically analyze it as a whole, whereas the lung is built by tens and hundreds of thousands of cells. So the cell is the smallest unit of the living organism that carries the organ, its function. And we have different cells in every organ. We call epithelial cells. These are the cells of the lining of the lung. There's endothelial cells, the cells that carry the blood, macrophages, other types of cells, inflammatory cells. And until recently, there was no way to measure how the genes in every one of these cells change. And what we announced actually in the recent conference was what we call the pulmonary fibrosis or the IPF Cell Atlas. It's basically the first generation of a whole catalog of every cell in the human lung and also in the fibrotic lung and how it has changed in health and in disease. This is not only the work of my group. There's 4 groups that published work and shared data. What is also unique with it, something very special. Usually when scientists discover things, they submit them to scientific journals and they only share the complete data after the publication comes out. We decided, and part of it was as a feeling of a commitment to the community, is that we will basically share the data before publication. So if you go to ipfcellatlas.com, ipfcellatlas.com, you will actually have access and you could find how every cell in the pulmonary fibrosis lung changes and also how every gene is changed in its expression. This is probably not very helpful to a patient or their family, but it is extremely helpful to industry and scientists because we took all this data, 300,000 cells from 90 patients. Every cell has 10,000 of genes. And now we put it in this database so that every person that's interested or may have a potential drug could look at it and say, oh, does my molecule actually, is it a target in pulmonary fibrosis? And we hope that this will attract the interest of many more researchers. The other thing is that when we did it, we actually discovered new things. And the most important thing we discovered is actually we found a new family of cells. We call them aberrant basaloid cells. It doesn't really matter. But these cells are relatively rare. They show up only in the lungs of the patients with pulmonary fibrosis. They're very different from normal cells. And it looks like that if you could modify their properties, maybe you slow down or stop the disease. We didn't know that these cells exist. Now, in retrospect, when I think about them, I look at pulmonary fibrosis biopsies all the time. I've seen these cells. They looked at me. But because we didn't have this profile, we could not describe them. And we actually gave them wrong attributes, and now we can correct. So we believe that these cells could be really important novel therapeutic target in pulmonary fibrosis. So we're really excited about it. The way you want to think about it, if you ever visited a star observatory, like, think about the difference when you look at the sky just with your naked eye, then you look at them with a telescope, and then when you look at the information that comes from the Hubble telescope. So what we have now for the pulmonary fibrosis lung is the Hubble telescope, and it's really exciting.